Now, just because so many people asked me about it before, what does that say? That says the absolute value of ln x, which is really just a lazy way of saying log base e of x. Does anyone know why it's an n? Does anyone know what the n stands for? Natural. It stands for natural because when you're thinking about logs, right, the natural base to use is e, okay? Why e? 2.71, blah, blah, blah. We'll dig into that a little more further when we get to exponentials and logs, which is a whole own topic. But suffice to say at the moment, the real kind of work with logs and functions, all is in base e, okay? We only start you off with like base 2 or base 4 or base 8 because you can do the mental arithmetic on those, okay? You can work out what log base 2 of 8 is because 2 to the power of something equals 8. You can work out the numbers on that. But this is some irrational, awful mess, right? But it's where all the interesting maths comes from. Anyhow, what does this thing look like? Well, think about it without your absolute value signs on it, okay? It looks like that. There you go, okay? In fact, it's a mirror image, I'll just draw it in. It's a mirror image of e to the x, okay? If you turn your head 45 degrees, okay? If you put y equals x in there, it's an exact reflection across. We'll talk a little more about that when we go into inverse functions, okay? But the reason why I draw this out is because we're familiar with e to the x. We know it has an asymptote. It has an asymptote where? It has an asymptote at y equals 0. Get in the habit of, asymptotes are lines. They're not points or values, right? So y equals 0 is a completely different asymptote from x equals 0. So don't say 0. Say what the asymptote is. If this guy has an asymptote of y equals 0, then this guy will have an asymptote of x equals 0, which is the actual one I'm interested in. Okay, so I'm approaching the y-axis in there, 0. Just like I have a y-intercept here of 1, I'll have an x-intercept here also of 1, right? So now I have all my critical points, and now I apply my absolute values, okay? I clearly have this part over here greater than 1, which is all fine. You get the idea. Happy times, okay? But then I have this part of the graph that's negative, right? So what do I do with it? It flips up. It flips up, okay? So it's going to do this. And approach the same asymptote, right? Because if I flip over x equals 0 vertically, it's still x equals 0. Hooray. So there's your graph. You don't even have to move the axis, the asymptote. Now, when you get to this one, and this is actually a critically important function for us. It's not just I'm putting absolute value signs wherever I want. This actually comes up when we look at the topic of integration. So just make a mental mark. When we get to that, this guy will appear. What does this mean? What does this mean? I'm going to refer back to like the algebraic idea of what happens when you apply absolute values. Okay? I say when x is less than 0. When x is less than 0. What's this thing equal to? Y should be equal to log of. Now I'm taking the negative case, aren't I? So it's log of negative x, right? And then when x is positive, I just have regular log x. That's the positive case. Okay. Now hold on a second. This is a bit interesting, right? Come back over here. Why is it that the log graph doesn't appear on this side of the Cartesian plane? Why doesn't it appear? Yeah, right now.
Because it approaches the asymptote and it never crosses to the other side.
Good. It never gets there. But in addition to that, I mean, we know other functions, just to play devil's advocate, we know other functions that do this, but they do cross over the other side. For example, 1 on x, it does that. Has an asymptote in the middle, but he has no problem appearing on the other side of the asymptote, right? But log x does. Why doesn't log x ever cross over to this side? Yeah, do you want to try?
Because if you put a negative value where x is in a log, it doesn't bring up the solution.
Okay, let's think about this, right? Let me come back to this guy, right? Because you think, oh, I can numerically do this, right? Suppose I put in this. Okay, now we then pose the question, what does this mean? This means, tell me the number that when I raise 2 to that power, whatever number you're thinking of, I get negative 8. And there isn't a real number that does that, right? You can put in astronomically large numbers, 2 to the 10, 2 to the 100, and you just get really big numbers. You could put in really small numbers, really negative numbers like 2 to the negative 10, 2 to the negative 100, and all you get is really, is really small numbers, but you never get negatives, right? You never cross over to the negative x, right? Aha. Unless you do this thing, right? What does this mean? What does it mean when you have a negative sign over there, right?
Is it kind of like, you know, how you have, when you have a negative number of the square root, it doesn't work. So basically doing that is getting rid of the negative?
Yeah, kind of. Okay, so think about this. Think of an example. Let's take x equals, it's natural log. Okay, so negative e. Okay, everything has to be in e's, otherwise my numbers are going to be disastrous. Okay, when x equals negative e, I'm in this domain. Okay, so this law applies, not this one, right? So y will equal to log of negative e, right? Which is log of e, which if you, in case you can't remember, it's log base e of e, which means what's the number that I raise e to in order to get e, and the answer is 1. Okay, so hold on a second. We were just saying logs don't make sense over here, but they do if you slap an absolute value sign on here. Think back to definition 1. It means, absolute value sign means take the positive, right? So that means you'll always get something sensible. Even if you start with something that shouldn't make sense, the absolute value will make it make sense. Okay. So if I were to graph these, if I were to put them all together, right? Oops, my aim's not very good, but okay. You're gonna have your regular log graph. See, within x is greater than or equal to 0, you got regular old log x. Okay. But when you look at values to the left of the axis, you're gonna get the same thing, just over there, right? 1, -1. Okay, that's an interesting case. Think about that guy, right? X equals -1. It'll be this case, right? So it's going to be log of -1, which is log of 1. And what's the number that if you raise e to that, you'll get 1? And the answer is 0. And that's why it's an intercept. Okay? So applying the absolute value sign gives you this function. It gives it symmetry, just like the original absolute value of x also has symmetry. It's the same symmetry because it's in there, right?